live. I'm going live. I'm live. Yeah. I am live. So where is this? Why is it not showing here? Started streaming less than a minute ago. I don't know. Okay, let's run this. Let's run this. But why isn't it showing? 2 likes. Okay, 2 likes. Somebody is liking something like. Okay, what is this? What am I doing? Oh yeah, I have to this code. Where is my code? Copy. Hey, what did I undo? And I need some brightness. I can't see my own screen. Yeah. And paste. And enter, 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 enter. Oh my god. So now if I have to say, let's say I am making one hash include stdio.h hash include io stream using namespace std, yeah, and remain. And what I'm doing is that I'm printing one brick game. Not a brick game, yes, it's a brick game, and I want to see if a sentient being, a sentient C++, I mean I'm using Quantum C++, Quantum++, so I want to see if it can select the part of the brick by its own decision, by its own intent, but it's going to be difficult. And oh yes, I need to cut this. So maybe I shouldn't have cut it. Anyways, I don't know what is going in the chat. Maybe I should see the chat. No, just print it. No, I want to see the chat, man. Okay, so I will see out. I'll print this dot 3 4 1 1 2 3 1 2. 3 is enough. I think 3 is enough. And but I need to update every time, so I need to a game loop for this. Okay, I'll make a game loop for that also, and I'll write new line for int I equal to 0, I less than, let's say around 1 2 2 10 I plus plus, and so second one, if I mod 2 equal to 0, then see out 3 dots because we need empty space, and a new line, else see out. What can be done is let's say we'll put one hash, random. So yeah, let's put it in mod 10. If I equal to I mod 3 equal I mod 3 equal 0, then we'll put it at cout. The block will be here, and a new line, else if I mod 3 equal to 1, and cout, it will be in the middle, dun, 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 and a new line, and a new line, and a new line, and a new line, else cout. It will be on the side, dun, 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 a new line, and this is done, and there will be 10 of them. Okay, let's run this. Bricks.cpp. Okay, g++ bricks.cpp. Okay, and what I'll write is a dot out. Okay, pretty good. This is pretty good. So in the end I should print finish line. Maybe not. Yeah, I should print the finish line in the end. See out and ding, ping, 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 ping. Yeah. So this is it. So I'll write. This is the output. So out.txt. Yep. So this is the output. Now I will run on the sentient. I don't know what to do here, but I'll using. Why am I using this std? Using namespace std. Using namespace. Hey, am I in YouTube? I'm live. I am live. Yeah, I'm live. I'm live. Subscribe to whose intro this is. Hey. So what's this called? Still to gates and states. What are these circuits? It's pretty cool. Using namespace zero state. Spy. The result of applying the bit with get x on this is display result. Control not. The result of applying the gate C not on 10 is display result. The result is U. I want to see the output of this code. Control A, Control C, and home, and sentient, and space. Control S. Display gates and states. Gates. No. GNS gates and states.cpp. Right. Gates and states. Output gates and states. States. What? Gate and states. Gates and states. What? Stop, no? Or is zero every so. Control U gate. Control U gate. Right. Okay. Gate. It's in stage the result of applying the bit flip gate X on 0 status. So it flipped. It flipped from 10 to 01 or what? Zeros. Okay. Sentient. CR display state 0. Let me write display state 0. I need to display this. I want to display this state 0. Where is it? This one. So using namespace std. Display st z0. What's a psi? Can I write it? Right. So how do I understand these states? These states are like, I just want to see what happens when I put a state here. What do I copy there? Maybe I will flip, to flip or not to flip. That is the question. How to answer a question, how an intent is created. How to create an intent. I just want to know it. Okay, here is the zeros. Where is it? 100. Ah, it flipped. So how do you need a quantum computer for that? Maybe I don't know. I want to see real quantum programs. I want to see a quantum algorithm. So quantum algorithm on what's that called? That means bit flip gates. How an intent is created that can make a computer sentient. Yeah. 3-bit quantum circuit. Introduction to quantum algorithm. No. Yes. There's something here, but is it cited? I don't read any research papers because it looks a bit like it is what you call copyright. Let's read on Wikipedia. Okay, there are some quantum. Maybe if I write quantum algorithms, some algorithms, wiki, quantum algorithm, quantum logic gate, not this one. Wow, algorithms based on Fourier I don't even know what is a Fourier transform. I've heard about it. Algorithms based on quantum walks. What's a quantum walk? A quantum walk is a quantum analog of a classical random walk which can be described by probability distribution over some states. A quantum walk can be described by quantum superposition over states. Okay, quantum walks are known to give exponential speedups for some black box problems. They also provide polynomial speedups for many problems. A framework for the creation of a quantum walk algorithms exists and is quite a versatile tool. Actually, those voltages can be used, no? Where is that? Yes, this one. Generating a random qubit gate U. This is a gate, so if I want to C0 on 10, no? Let's put a C0 on 0. Let's put a C0 on 0. Oh, this is fun, man. Gate C0 result U. Display psi result U into psi. U is gate X. Okay. Let's put a C0 on 0 U. Where is U defined? Oh, CMAT U. Okay. What is a CMAT? I don't know, but I want to know what happens when I put a C0 gate, which is of type CMAT. PV psi gate into C0. Okay, psi into C0 like this. Okay, and how do I reprint the results? See out display. PV, my first one. Anyways, so what we can do is remove this. Thank you, and remove all these others. Where am I? Yes, this is the correct. Let's stop this and remove this and remove the. Okay, better than that. What can be done is I can comment out the entire thing, put it here and put it there and put it here. You have to return a 0 maybe because the int is a return type is an integer, therefore I have to return a 0. So here again, gates and states. So how to use those voltages? Oh, not a member of C0. What is matrix complex double agent vectors? See what they have used this C. Oh, this C0 cannot be applied on a single state. Alright. Quantum algorithm. So where do I find it? Quantum. Oh, not here. Gates in quantum computing. What are those gates? I need a list of them. Quantum logic gate. Ring, ding, 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 ding. So these are poly X. What is the matrix? Alright. And why do we get those voltages? I want those voltages. Hey, it's not a voltage. I think it's just a number. It's a complex number. I have no idea what this is about. And how do we extract all of these values? So there's simply probability, right? This is a very difficult thing to do. I think how to do it, how do the computer decide that it has to move to the left or the right? How does it decide on its own without any instructions? How to do it? And I don't think this is about how. The question is not how here, the question is who is deciding, who, when and where. It's not about how, why and what, it's about who. And here a computer is becoming sentient, so we have to ask who is this computer? And I have no idea how to do that. Who are you, Mr. Computer? And this is not a quantum computer, so this is another matter. So who is this? How do we ask the who? So difficult. Okay. Quantum gate video game. No, my brain is out of touch. See, not. Okay. How? On who? So because if we are using and how to extract the value of the first, so quantum state, now so how, so if two quantum states are superposition, I want to read about superposition in quantum computing. What's it and what's it about? Okay. Quantum superposition is a fundamental of quantum mechanics. It states that much like waves in classical physics, any two or more quantum states can be added together, superimposed or superposed, and the result will be another valid quantum state. And conversely, that every quantum state can be represented as a sum of two or more other distinct states. Mathematically, it refers to a property of solutions of Schrodinger's equation. Since the Schrodinger equation is linear, any linear combination solution will also be a solution. Okay. An example of physical observation wave formation quantum system is the interference peaks from an electron beam in a double slit experiment. The pattern is very similar to the one obtained by diffraction of classical waves. Another example is a quantum logical cubic state as using quantum information processing, which is a quantum superposition of basis states, zero state and one state. Here 0 is a Dirac notation for the quantum state that will always give the result 0 when converted into classical logic by a measurement. Okay, likewise, one is a state contrary to a classical bit that can only be in a state corresponding to 0 or a state corresponding to 1. A qubit may be in a superposition of both the states. This means that the probabilities of measuring 0 or 1 for a qubit are in general neither 0.0 or 1.0, and multiple measurements made on the coefficients and the states in one configuration. It's like probability. It's like it will come in between 0.0 and 1.0. How to get that value? I want it. This is a complex number. The principle of quantum superposition states that in physical system may be in one of many configurations, arrangements of particles or fields. Then the most complex, most general state is the combination of all these possibilities, where the amount of these configurations is specified a complex number. What? The principle of quantum superposition states that if a physical system may be in one of many configurations, arrangements of particles or fields, then the most general state is a combination of all these probabilities. I don't understand why the principle of quantum superposition states that did you have understood? If a physical system maybe in one or many configurations, arrangements of particles or fields, then the most general state, if a physical state is one of many configurations, most general state is a combination of these possibilities, where the amount of each configuration so these states are specified by a complex number. For example, if there is two configurations labeled by 0 and 1, the most general state would be C00 and C11. Plus, iska plus kariye. Where the coefficients of complex numbers describe how much goes into each configuration. The principle was described by Paul Dirac as follows. This is Anton. The general principle of superposition of quantum mechanics applies to the states that are theoretically possible without mutual interference or contradiction. I don't want to read this part, I want the examples. For an equation describing a physical phenomenon, the superposition principle states that a combination of solutions to a linear equation is also a solution of it. When it's true, this is true, the equation is said to obey the superposition principle. Does if step vectors f1, f2, and f3 solve the linear equation of this is a phi, then this is a phi, what is this called? C1 f1 plus C2 f2 plus C3 f3 would also be a solution. In each state, in each C is a coefficient. The Schrodinger equation is linear, so quantum mechanics follows this. For example, consider an electron with two possible configurations, up and down. This describes the physical system of qubits, up and down. Okay, general one. It is the most general state, but these coefficients dictate probabilities for the system to be in either configuration. The probability for a specified configuration is given by the square of the absolute value. Okay, this is like probability. So if we have an actual quantum computer, that time its power can be seen that, oh yeah, this is working, like sometimes it is working in this direction, sometimes it's working, so it is creating intent here and there, and it is finding the best solution. So we don't need to do a reinforcement learning or some kind of algorithm to get it done. So it does by intent, like humans do. It becomes a human, it becomes sentient. Actually, this is sentience. The computer knows that it is a computer. It becomes a who, not a what, after quantum computing. The electron is one of the most of those two states for sure. It becomes a person. It becomes humane. It is very important for robotics, I think, because if a computer knows what it is or who it is, that time it won't harm humans. I think maybe we don't know what a computer will intend to do, but yes, it is equally dangerous actually. Oh God, this is the why does these things exist? Anyways, okay, physical system is a qubit. So now if I have to do a probability, if I do at least one, I need a real quantum computer, some kind of online. We'll see to that. I don't know who will run it for me, but I want to see it for myself. Okay, for example, consider an electron with two possible configurations up and down. This describes the physical system for the qubit C1 and C2. So if I add this, so how do I add two states? I have already done that here. It's multiplication. This is done down 0. So what this is, U is gate X. What is gate X? If I want to add this, how add gate, addition gate, add gate, addition gate in quantum computing. Yes, addition gate in quantum computing for 0 and 1 states. This is add gate. There has to be an add gate to quantum computing. No, I want a quantity. Should I open this? I don't know. Wikipedia is pretty safe. I just want to look at Wikipedia. Anyways, so where is the addition gate? So Control F, add, addition, and where is this? Unitary inversion of gates. And what is this? The Hadamard transform, parallel. Wow, serially weird wired gates. Wired gates. Serially wired gates. Universal quantum gates and Ising ZZ coupling gates. Wow, what are these things? How do I add? If I put a dot, if X, this is the gate X, right? C mat U gate dot X, and then we do get result U into what did it do? I can't see. There's too much brightness. Yes. So sorry. Okay. So this is state 0 and this is a CMAT. This does not work. We'll just see it. Okay, display here. This is working. CMAT U. What is the CMAT? I want to see what the CMAT is. CMAT. Come on. There's no CMAT. Oh, this is for the language specific. And what's a cat? What is a cat? It's a bracket. Wow. Quantum states are typically measured as a cat. Bracket. Acha. Bracket. Notation is a combination of bracket. Cat. So, cat. Okay. Cat 0. Cat 1. Pretty good. So, what is this gate and what is a plus gate? What is a plus gate called? It is there in code forces. Code forces. Quantum computing. Okay, Microsoft Q Sharp quantum computing coding contest. Okay, fine. Where is winter 1999? And the oldest one, warm up. Wow, I've solved this. So plus, oh yeah, I want this. plus state or minus state. Yeah. Where is the code? You're given a qubit in a 0 and integer sign. Your task is to convert the given qubit state to plus. What the heck? Equal to 1 by square root of 2, 0 plus 1 if sign equal to 1, or minus 1 by square root of 2, 0 minus 1 if sign is minus 1. What is the sign? The sign is given. You have to implement an operation which takes a qubit and an integer as an input and no output. The output of a solution is the state in which you left the input qubit. Your code should have the following signature. Alrighty. Then I become carry. Yeah. What does this mean? If sign is x is x and h. X and h. Where is the tutorial? So this is how to do this. How to yes. So you are given this solution. Look up a list of quantum gates, for example, quantum logic gate editor in Wikipedia. Okay, thank you. For the first gates, there will be the Hadamard, a gate which converts 0 to plus and 1 to minus. Let's use it to create a required state. The given qubit starts in 0 state. So for the case of sign equal to 1, is sufficient to apply a Hadamard gate to it. For example, Hadamard gate is the poly gate. And what are these states? Plus and minus states. What are these states? What do they do? Okay, B, general Bell state. You are given 2 qubits in state 0, 0 and an integer index. Your task is to create one of the Bell states on them according to the index. What? 2 qubits state 0, 0 and integer index. What is integer index? What is an integer index? Another thing is given. Integer index is given. Okay. 2 qubit states. Your task is to create one of the Bell states. And what is the Bell state? On them according to the index. B0 is 1 by square root of 2, 0, 0 plus 1. Why the square root of 2 is given in 0, 0, 1, 1, 0, 0, 1, 0, 1, 1, 0, 0, 1, 1, 0. Plus minus. Okay. You have to implement an operation which takes an array of 2 qubits and 2 qubits as an input and has no output. The output of a solution is okay. Solution. Let's start by generating a B0 state. Oh my god, this is so much to read, yo. And what's a Bell state? A Bell state, a concept in quantum information science. What is a quantum information science? A specific quantum states of 2 qubits that represent as the simplest and maximal examples of quantum entanglement. What is a quantum entanglement? I've heard this about entanglement and superposition are the most important things in quantum computing, and I don't know what they are. I think it's like being in 2 places at the same time, is something like that. It's crazy. Quantum entanglement is a physical phenomenon that occurs when a pair of groups of particles is generally integrated to share special proximity in the basis of the quantum state. The pair of groups can be destroyed independently, even when the particles are separated by a large distance. The topic of what is out of the brain, yo. Quantum information science is study, area of study based on the information science depends on quantum effects in physics. It includes theoretical issues in quantum computation. I think one who does quantum computing will become the richest man next. He will crack the Human Genome Project. It is like the next thing to do. Creating Bell states. It's an industry to get into. Really, this is an industry to get into. Application. I'll stop for some time. I want to see what. When I start this Sentient again, I'll come back in the stream.